Hello class! Welcome back to Billy and Joy's classroom. For today's lesson, we are going to talk about the nth term of an arithmetic sequence. So for this topic, we are going to try to look for the value of the nth term, the value of the first term, value of the common difference, and the value of n or the number of terms. So in our previous lesson, we define arithmetic sequence as a sequence of numbers whose difference between two consecutive terms are the same. So they have common difference. So that is the unique for arithmetic sequence. In arithmetic sequence, we have the formula, that is the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, wherein a sub n is the nth term, a sub 1 is our first term, n is the number of terms, and d is the common difference. So let's now try to find the a sub n or the nth term. So we have here a problem. Find the 21st term of the sequence 4, 7, 10, 13, and so on. So the first step is we are going to list all the given. So we are looking for the a sub n or the nth term. We have given, which is a sub 1, that is equal to 4. N is also given, that is 21. And d is the common difference, which is 3. So we obtain d by subtracting 7 minus 4, that is 3. 10 minus 7 is also 3, and then 13 minus 10 is also 3. So that is the common difference, 3. We have the formula for the arithmetic sequence, that is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So substituting the value, since we are looking for the 21st term, so we have a sub 21, that is equal to 4, which is our a sub 1, plus the quantity of n minus 1, so our n is 21 minus 1 times the common difference, 3. So first, we are going to subtract 21 by 1 because it is inside the parenthesis, following the PEMDAS rule. So we have a sub 21 is equal to 4 plus 20 times the common difference, 3. Then, next, we are going to multiply 20 times 3, which is following the rule for the PEMDAS rule. So we have a sub 21 is equal to 4 plus 60. That is the product of 20 times 3. Then now, we can add 60 plus 4. So the value of our nth term, which is the a sub 21, is equal to 64. Okay? So for this time, we are going to try to look for the value of the first term, or the a sub 1. So we have here a problem. The 16th term of an arithmetic sequence is 48. If the common difference is 3, find the first term. So first, we are going to list all the given. A sub n is equal to a sub 16, that is equivalent to 48. So that is given in the problem. So we have to look for the first term, that is a sub 1. Then we have n is equal to 16. Then the common difference is 3. That is also given in our problem. So using the formula for the arithmetic sequence, a sub n is equal to a sub 1 plus n minus 1 times d. So let us substitute the value. A sub 16 is equal to a sub 1 plus the quantity of 16 minus 1 times 3. So the value of our 16th term is 48. So we're just going to substitute in the a sub 16. So we have 48 is equal to a sub 1 plus 15. Okay, that is the difference of 16 minus 1 times the common difference 3. So we have 48 is equal to a sub 1 plus 45. So the 45 is the product of 15 times 3. Okay? So this time we are going to combine similar terms here. So we cannot combine a sub 1 plus 45 because they are dissimilar. So they are unlike. So what are we going to do is apply the addition property of equality so that we can cancel out 45 so that a sub 1 will remain. Or we're just going to transpose 45 to the other side of the equation. Okay? So applying the addition property of equality, we're going to subtract 45 in the right side of the equation. So we are going to subtract also 45 from the left side of the equation. So we have 45 minus 45 is equal to 0. Now we have 48 minus 45 that is equivalent to 3. So therefore, our a sub 1 is equal to 3. Okay? So this time, let us find the common difference D. Given the problem, find the common difference of the arithmetic sequence with the given a sub 3 is equal to 11 and a sub 5 is 19. So we have here problem, two non-consecutive terms. Okay, so we cannot be able to identify the common difference easily. So we have here the sequence of numbers that is 2 unknown, then we have the a sub 3 that is 11, then a sub 4 is unknown, then a sub 5 is 19. So what are we going to do with this? So let us assume a sub or 11 as our a sub 1. Then we have a sub 2, then a sub 3. Okay, so for the meantime, 11 will be our first term, then 19 will be our third term. But originally, 11 is our third term, and then 19 is our a sub 5 or the fifth term. So now let us write the given. A sub n is equal to a sub 3, that is equivalent to 19. Okay? Then we have a sub 1, that is 11. Then n, it's 3, so that is the number of terms. Then we are going to look for the common difference D. Okay? So using the formula for the arithmetic sequence, that is a sub n is equal to a sub 1 plus n minus 1 times D. So substituting the value, we have a sub 3 is equal to 11 plus quantity of 3 minus 1 times the common difference. So our a sub 3 for the meantime is 19, that is equal to 11 plus 2, which is the difference of 3 minus 1 times D. So we are going to multiply now D times 2. So we have 19 is equal to 11 plus 2D. So take note, we cannot combine 11 and 2D. So therefore, we are going to apply the addition property of equality, or we are going to transpose 11 to the other side of the equation. So we have 19 minus 11 is equal to 2D. So 19 minus 11, we have 8 is equal to 2D. Now we are looking for the value of D. So therefore, we need to cancel out 2 by dividing both sides of the equation by 2. So we have 8 divided by 2 is equal to 2D divided by 2. So cancel. 2 divided by 2 is equal to 1. So we have now 8 divided by 2 that is equal to 4. So our common difference now is 4. Okay? Next. So this time we are going to find the number of terms for our n. We have here a problem. How many terms are in arithmetic sequence whose first term is negative 3, common difference is 2 and the last term is 23. Okay? So we have here our given a sub n is equal to 23, a sub 1 that is equal to negative 3, then n is missing, then d or the common difference is 2. So using again the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Substituting the value, we have 23 is equal to negative 3 plus n minus 1 times d. So applying the multiplication property of equality, we are going to multiply 2 times n, then 2 times negative 1. So therefore, we have 23 is equal to negative 3 plus 2n minus 2. Then observing the equation, we can combine negative 3 and negative 2. So negative 3 plus negative 2, we have 23 is equal to negative 5 plus 2n. Then we are going to transpose negative 5 to the other side of the equation. So we have 23 plus 5 is equal to 2n. So we can now combine 23 plus 5. So we have 28 is equal to 2n. Now we are going to cancel 2 so that n will remain because we are looking for the value of n. So by dividing both sides of the equation by 2. So 28 divided by 2 is equal to 2n divided by 2. So cancel 2. So we have now n is equal to 14. Okay? So that's all for today. Thank you and goodbye.